Hey everyone, I hope you're doing well today. In this video, let's talk about solving one-step equations, but specifically in this one, let's try just solving the equations that have subtraction as the operation. To solve these one-step equations that have subtraction as the operation, we really have two properties that we need to use. The first one is going to be the addition property of equality. Because subtraction is the operation we see in each of these equations, addition is the inverse operation, so by adding a value to both sides of the equation, we can then cancel out one of the constants. Once we're done adding some number to both sides of the equation to cancel out the constants and getting 0, we're then going to use the identity property of addition and just get rid of the 0 that we see. Throughout this video, we're going to use the addition property of equality and the identity property of addition to solve each of these equations. Let me just show you real quick the types of equations that we're going to be solving. We'll try a couple that look like this, then a couple that look like this, a couple that look like that, then a couple like these, and we'll finish up with a couple of those. Notice how all 10 of these equations have subtraction as their operation. Real quick before we get into solving each of these equations, if you could give the video a thumbs up, it really helps out the channel more than you know. Now let's go ahead and try out these 10 practice problems. I encourage you to grab some paper, something to write with, and let's do some math together. In example 1, we have the equation x minus 4 is equal to 17. To solve for that x, we have to first notice this minus 4 that's on the same side on the left of the equation, and we're going to have to go ahead and add 4 since opposites always equal 0 when you add them together. By adding 4 to both sides of the equation, we're really using that property called the addition property of equality. This minus 4 and plus 4 are going to combine to make 0, so we're going to write x plus 0 on the left side of the equation. On the right side of the equation, 17 plus 4 is equal to 21, so we can write 21 on the right side. When we see plus 0 in an equation or an expression, we don't need to write it from the identity property of addition, which just says that adding 0 has no effect, so we can say that x is equal to 21. This would be the solution for this equation. For example 2, we have the equation 11 is equal to w minus 15. And to solve for w, notice how we have this minus 15 that's on the same side to the right of the equation. And to get rid of it so we have w alone and have it solved for, we're going to go ahead and add the opposite, which is going to be adding 15 to both sides. By adding 15, which is the opposite of minus 15, we're going to be able to get 0. We can add 15 to both sides of the equation because we're using the addition property of equality. On the left side of the equation, 11 plus 15 is equal to 26, so we can go ahead and write that. And on the right side of the equation, the minus 15 and plus 15 combine to make 0, so we can write w plus 0. We can drop the plus 0 from the identity property of addition and simplify this and say that 26 is equal to w, or turn it around and say that w is equal to 26. There's our solution. For example 3, we have the equation 13 is equal to y minus 18. To solve for y, notice how we have this minus 18 on the same side of it. To get this y alone and solve for it, we're going to need the opposite of a minus 18. So we're going to go ahead and add 18 on the right side, but if we do it on the right, we have to go ahead and do it on the left to make sure that we're balanced on both sides of the equation. This right here is using the addition property of equality, adding 18 to both sides. On the left side, 13 plus 18 is equal to 31, so we can go ahead and just write that on the left side. And on the right side, the minus 18 and plus 18 combine to make 0, so we can write y plus 0 on the right side of the equation. Let's go ahead and drop that 0 using the identity property of addition, and we can simply say that 31 is equal to y, or turn it around and say that y is equal to 31. There's our solution. For example 4, we have the equation negative 8 is equal to x minus 5. To solve for x, notice what we have on the same side of it, which is this minus 5. And to get rid of that minus 5, we're going to go ahead and use the opposite and add 5 to both sides of the equation. By adding 5 to both sides of the equation, we are going ahead and using the addition property of equality. On the left side, negative 8 plus 5 is equal to negative 3. And on the right side, this minus 5 and plus 5 combine to make 0 since they're opposites, so we can write x plus 0 on the right side of the equation. Let's go ahead and drop the 0 by using the identity property of addition, so we can say that negative 3 is equal to x, or we can turn this around and say that x equals negative 3, whatever floats your boat. For example 5, let's solve the equation negative 15 is equal to k minus 19. To solve for k, notice how we have this minus 19 on the same side of it. And to get rid of it, we're going to use the opposite, which is going to be a positive 19. So let's go ahead and add 19 to both sides of the equation. When we do this, we're really using the addition property of equality. We're adding something to both sides of the equation. On the left, negative 15 plus 19 is going to equal positive 4. And on the right side, this minus 19 and plus 19 cancel out to make 0, so we can write k plus 0. Let's go ahead and drop that 0 by using the identity property of addition, so we can say that 4 is equal to k, or the value of k is equal to 4. There's our solution. For example 6, we have the equation b minus 4.7 is equal to 2.9. To solve for this b, we have to notice that we have this minus 4.7 on the left side, and to get rid of it, we're going to use the opposite and add 4.7 on both sides of the equation. So going ahead and writing plus 4.7 to both sides, we're really going ahead and using the addition property of equality, or A.P.E for short. On the left side, these opposites are going to combine to make 0, so we can write b plus 0 on the left side. On the right side, 2.9 plus 4.7 is equal to 7.6, so we're going to go ahead and write that along the right side. Let's go ahead and drop that 0 by using the identity property of addition, so we can conclude that b is equal to 7.6. There's our solution. For example 7, let's solve the equations. For example 7, we have c minus 7.2 is equal to negative 3.9. To solve for c, notice how we have this minus 7.2 on both sides, so to get rid of it, we're going to have to go ahead and add 7.2 to both sides of the equation. By doing so, we're really just using the addition property of equality. Same old. On the left side, these opposites are going to cancel out, so we can just write c plus 0. And on the right side of this equation, this negative 3.9 plus 7.2, which is the same thing as 7.2 minus 3.9, and that's equal to 3.3. Let's go ahead and drop that 0 by the identity property, and then conclude that we know that c is equal to 3.3 for this problem. There's our solution. For example 8, we have the equation d. For example 8, we have d minus 1/2 is equal to 2/3. So we have this minus 1/2, and to get rid of it, we're going to do the same thing we've been doing and just add fractions this time. So we're going to add 1/2 to both sides of this equation. By doing so, once again, we're using the addition property of equality. The opposites on the left are going to cancel out, so we can just write d plus 0. And on the right side, to add 2/3 and this 1/2, we're going to need common denominators. And 3 and 2, they really meet for the first time at 6. That's going to be their LCM or LCD. So we're going to multiply both of these fractions so we can get 6 as a denominator. 2/3 is equivalent to 4/6, and this 1/2 is really equivalent to 3/6. So we're going to add on 4/6 plus 3/6. 4 plus 3 is 7, so I'm going to say that's equal to 7/6. Let's go ahead and just drop that 0, and we can say that d is equal to 7/6. You can just leave it like that if you'd like, or if you wanted to write a mixed number, you could do so as well and say that d is equal to 1 and 1/6. Either one is fine. For example 9, we have e minus 3/4 is equal to negative 9/10. To solve for e, we need to first take a look at this minus 3/4 that's on the same side, and go ahead and do the opposite and add 3/4 to both sides of the equation. By doing so, we're once again using the addition property of equality. On the left side, these opposites are going to cancel out, so we can write e plus 0. And on the right side, taking a look at these fractions, we need common denominators. So looking at 10 and 4, trying to think what is their LCM. I think 20 is the LCM for those. So we can go ahead and multiply 9/10 by 2 and 2, so we get 20 on bottom. And to get 20 on bottom for 3/4, we can multiply by 5 and 5. So let's see. This negative 9/10 is equivalent to negative 18/20. So we're going to use that version. And for the 3/4, if we multiply by 5 and 5, we are going to just use this 15/20 instead. So going ahead and adding negative 18/20 plus the 15/20, well, the negative 18 is more negative than the 15 is positive. So we can say that this 18 minus 15 is going to be negative 3. So we'll write negative 3/20. Let's go ahead and drop that 0 here and say at the very end that e is equal to negative 3/20. There's our solution. For example 10, we have the equation f minus 2 and 1/4 is equal to negative 1 and 2/3. To solve for the value of f, first take a look at this minus 2 and 1/4 that's alongside the left, and go ahead and add 2 and 1/4 to get rid of it. By doing so, we're just using the addition property of equality for one final time here. These opposites are going to cancel out along the left side, so we just have f plus 0. Let's go ahead and rewrite this negative 1 and 2/3 as an improper fraction. So 1 times 3 is 3, plus 2 is going to be 5. So this is equal to negative 5/3. And for this 2 and 1/4, well, 2 times 4 is 8 plus 1 is 9. So that's equal to 9/4. To add these fractions together, we do need common denominators. So I'm just going to write that down here. So we have negative 5/3 and we have 9/4. Their denominators are 3 and 4, which meet at 12 for the first time. So we can multiply this one by 4 and 4 to get negative 20/12. And for the 9/4, we can just multiply by 3 and 3 on top and bottom, and that's going to equal 27/12. Now that we have common denominators, we can combine these two fractions, so negative 20 plus 27, or just 27 minus 20, whatever is easier to think about, that's going to be equal to positive 7/12. Going ahead and dropping this 0, as we've been doing so for all the other examples, we can conclude that f is equal to 7/12. There's our solution. And that wraps up this video on 10 different examples on solving one-step equations that have subtraction as the operation, and by doing so in each example, we use the addition property of equality, and then we got 0, and then we just dropped the 0 by using the identity property of addition. Hopefully everything was clear and consistent, and you have a better understanding on how to solve each of these equations despite having fractions, decimals, or integers. And if you found this video helpful, please consider giving it a thumbs up and letting me know in the comment section down below. As always, keep up the great work, and I'll see you in the next one.